Hi, my name is Josh Kokatnur, and this is my lightning talk for the 2022 NC Space Grant Symposium. Through the space grant, I was able to work as an intern for Collier Aerospace and did some pretty cool work with cloud computing to speed up their structural analysis processes. So let's start with the background. HyperX is Collier Aerospace's main software product. They essentially pull in these finite element models, and the analysis that was run on those models usually by another program. And with that, we're going to create a new model. It's made up of these zones and structures you can kind of see at the bottom. And through this, we can perform optimizations on that model, run structural analysis, and perform more optimizations, and so on. So let's move to the main problem. The main problem is at large corporations, we start to have very large complex models that consist of terabytes of data, and on your average laptop could take weeks to run these analyses. So what we already have is we have a way to split up this model into a bunch of smaller subcomponents. But what we don't have is a way to kind of distribute the processing of these. So let's say a company already has an array of high-powered computers. We're going to have to design a specific process for them to be able to do that, but we don't have the functionality built into the program right now to do that. So, and also for smaller companies that maybe don't even have access to those high-powered computers, we want to make it so that they can use the program in the same way as any of those other companies. So here's the solution. We're going to use AWS or Amazon Web Services, and this is going to provide anyone with really all of their needs as far as cloud computing. You're going to be able to purchase computers that have terabytes of RAM and hundreds of super powerful CPU cores. So we're going to be able to pass in a very complex model to these services and be able to process it with our program with ease. And I've outlined the process for doing this on AWS and converted that into a PowerShell script that I've developed over the course of my internship. And what this is going to do is take in those files, transfer them to AWS, run our program on those compute instances that essentially run Windows like any other normal computer, and then pull down those result files and put them back into HyperX, just as if you ran the analysis on your own computer. So moving on to the process, some quick terminology. S3 is the cloud storage that AWS uses, where we're going to put all those files that we need. SSM is the systems manager that I'm going to use to remotely control these instances. And EC2 is just a short term for the computers that we're running it on AWS. So the process starts out, we start out in our software on the client side. If you choose, you split up the file into these multiple subcomponents. And my script essentially starts here, where you select all those files. It's going to transfer them to S3, where these AWS computers can access the files. And then SSM is going to allow us to start up these three instances. And then on each of those instances, start up HyperX for the amount of components we need. So because these instances are so powerful, we can run multiple instances at a time of HyperX on those computers to process all of those sub models as fast as possible. And then when all of this is done, it's going to pull in all the result files back to their cloud storage. And then all of that data is going to come back to the client. We're going to import it back into HyperX, and it's as if the processing never left the computer. So onto the results, we did a quick trial of the script. So we take an AWS instance that costs about $4 an hour to run and compare it to a pretty powerful laptop that we have. So we're able to get about 8 times better performance. On the bottom, you can see the time in hours. So for these config 1 and 2 were the larger files, we run these, and on the laptop, it takes, as you can see, about 25 hours, whereas in AWS, we were able to run it in about 5 hours. So just a quick overview of future work. I've designed the process here, proven that it works with AWS, and then we want to implement this into our program and make it so that it's accessible for really anyone. And this may include specific needs where some companies need to run on their local network, for instance. And that is all. If you have any questions, my email is right here. Thank you.